All right, hello, B and Alex once again. This is Thursday of the week, so this will be the last time that I'm talking to you for the week. I'll be posting you a celebration tomorrow for you to go ahead and do and send back to me. So today we've got to review sigma notation. Okay, you learned this in Algebra 2. I'm sorry, not Algebra 2, Pre-Calc. You learned this in Pre-Calc and should be okay on it, but we're going to be using it moving forward and talking about area and more definite integrals. So we will be talking about this thing called Riemann sums. So we'll have to know these basic sigma notation formulas. All right, so I got 4 of them. I'm going to go ahead and go through them here and get you started out. So if you've got the summation from I equals 1 to some number n. So this could be anything you want. We're just going all the way to somewhere. Of a constant. Okay, so this is like, for instance, saying, example 1 down here, from I to 7, or from 1 to 7 of 5. So that means basically you do 5 7 times. Okay, so this is a very simple one. All you have to do is do the constant number times n. Okay, so this one is very, very easy. Number 2, we've got the summation, again, from I equals 1 to n, this time of I, okay? I've used I in my examples down here because that's the way that your book is going to use I, and that's the way they have outlined it for you. So just keep in mind they could be X's at some point, but for right now we're using I's. Okay, so the formula for I is n times n plus 1 all divided by 2. Okay, so basically all we need to know is whatever that top number is. So say the top number is 5 in this case. Okay, so we've got 5 times 6 divided by 2, which would output us 15, because we do 5 times 6 is 30 and divided by 2 is 15. So that will output us one number for that spot. Okay, this will make more sense when we do the examples. It's okay. I've got number 3 here, from I equals 1 to n again, of I squared. Okay, so I squared has its own formula. It's going to be n times n plus 1 times 2n plus 1 all divided by 6. Okay, and if you really, really wanted to, you could do the formula from like getting from I up to I squared. It outputs you the same thing, but there's no reason to do it. You just know that this is the formula. So again, you're just plugging in whatever your n values are. Lastly, I've got the summation from I equals 1 to n of I cubed. Okay, so I've got n squared times n plus 1 squared all over 4, which looks an awful lot like that one above us. Okay, so these are our 4 formulas that we're going to use moving forward. So I've set up 3 examples down here. They get a little bit tougher as we go. Okay, so the first one, example 1, this is just a constant number. So this directly applies to formula number 1. Okay, all that I have to do to be able to figure out what this adds up to be, and let me show you exactly what I mean by adding what this adds up to be. Okay, this is telling me to plug in into the equation, this being the equation right here. Okay, on this one it's very short. It wants me to plug in the number 1, then plug in the number 2, then plug in the number 3, 4, 5, 6, all the way to 7. Now, on our equation right here, we don't have a place to plug in the number. So when I plug in 1, it would just be 5. And then when I plug in 2, it would just be 5 again. When I plug in 3, it would be 5. Plug in 4, it would be 5. Plug in 6, it would be 5. I'm sorry, I think I skipped 5. Yes, I skipped 5. So when I plug in 5, it'd be 5. When I plug in 6, it'd be 5. When I plug in 7, it would be 5. And I add all those up. Okay, so that's what this actually means. The easier thing for me to do would be to follow formula number 1 up here, where it says a constant number. All you have to do is multiply it by the top number. So I'll get 5 times 7, and I can tell you that summation equals 35. Okay, so it may make a little more sense here on example 2 when I show you that. What it wants me to do, and I am not doing this because it will take me a good minute, it wants me to plug in 1 into that formula, then 2, then 3, this being the equation. I didn't mean to say formula. It wants me to plug in 1 into that formula. So I would plug in 1 where I is. So 5 times 1 would be 5, plus 3 would be 8. And then it wants me to do 2. So 2 times 5 would be 10, plus 3 would be 13. Then do 3. So 3 times 5 would be 15, plus 8, plus 3 would be 18. Okay, it wants me to do that all the way until I get all the way up to 20. That would take forever, okay? Ain't nobody got time for that I'm going to leave it for you. I'm just going to do dot, 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 dot. Okay, so let's use the formula. Okay, there's a cool thing about these summations, though. Everything can be done separately. So when I have the summation of 5i plus 3, I can really do the summation from I equals 1 to 20 of 5i, and then I can just put a little plus sign and do a separate summation for 3. Okay, so another cool rule about these is constants really don't matter. They just come in at the end. So this 5 that is associated with the I right here, where I'm underlining, the 5i, I can really bring the 5 to the front of that summation, set up I equals 1 to 20 of I. And I have a formula for I. It's up here, number 2, top right. So it's n times n plus 1 divided by 2. N in our problem is 20. I'm going to write that formula again. N times n plus 1 divided by 2. Okay, n in our problem is 20. So in order to figure this out, I have to do 20 times 21 and divide whatever that is by 2. Okay, so you can calculate that. 20 times 21 divided by 2. That's going to give me 210. I should not have typed that in the calculator. I'm sorry, Alex. B would have done it. Okay, but we forgot about this 5. So that 5 still needs to come and ride right there in front of 210. So if I multiply that by 5, I've got 1050. Okay, that takes care of the left side. Now I got to take care of this right side over here where the 3 is. So I'm back up to the top right here. I'm pointing at it with my pen. Here you go. There's an arrow. Okay, that's where I'm at. Now I have to do it for a constant. And this directly applies to this first example that we did over here just a second ago and got a 35. And it applies to our first formula all the way up here top left where it's a constant and all you have to do is multiply it by the top number. So very simply, to do this summation, I just have to do 3 times 20, which is, shoot, it's not 40, which is 60. Do some simple math, and I've got 1110. Okay, so that is what that summation equals. So again, what that means is plugging in 1, plugging in 2, plugging in 3. So we did it right here. We plugged in 1, 2, and 3. I would have done 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, and added all those numbers up, and they will add up to be 1110. Lastly over here, example 3, I don't have a formula for that. If you notice, that doesn't apply to any of my 4 formulas right here that I've got them back on the screen again. So what I really need to do is just take this out to the side and figure out what I plus 1 squared is. Remember, you have to FOIL that. You can't just make it I squared plus 1. I know B would probably want to do that. So I times I is I squared. I've got I times 1 would be plus I. I've got another I times 1 would be plus I, and then a 1 times 1 would be 1. So this really says I squared plus 2I plus 1. So I'm going to bring it back over to my summation. But again, the cool thing about it is every piece can get its own part, okay, or can get its own summation. So I'm going to write that out separately. Ooh, that is not the correct symbol. If I do the summation from I equals 1 to 16 of I squared, then this 2I is going to get its own part. So remember, this guy gets its own part, own part, own part. So 2I is going to get its own, and this directly applies just like the 5 that we had on the last problem, okay? Can you see over here where we had this 5 and we relocated it out to the front? That's what we're going to do here with our 2I. Okay, so 2 is going to come out to the front. I'll have the summation. Whoa, that's too much, Josh. I'll have the summation from I equals 1 to 16 again of regular I, and then I've got one more I'll add. I equals 1 to 16 of 1. That one's going to be cake for us. It won't be bad. So I've got I squared. Remember, I have a formula for I squared. I'm going to take us up to it. It looks like it's right there in the middle of the screen. So n times n plus 1 times 2n plus 1 all over 6. I'm going to write that. N times n plus 1 times 2n plus 1 all over 6, with n being 16 in this problem. So I have 16 times 17 times 2n plus 1, so 2n would be 32, so plus 1 would be 33, all over 6. Okay. I don't have any numbers out in front, so I'm really just going to type that in. That outputs me 2992. All right. I'm going to take care of the second part here. Remember, this 2's riding out front, so at the end I'm going to have to multiply whatever I get by 2. But I'm going to use the formula for I, which I remember being n times n plus 1 divided by 2. So 16 is our n here, so I've got 16 times 17 divided by 2. I cannot do 17 times 8 in my head. 136, but this really isn't 136, is it? Because we've got to remember this 2 has to come down at the end. Okay. Lastly, I'm going to take care of this 1 out here. It's a constant. It's really just got to multiply by the front, so it's really just 16 times 1, so we're just adding 16. If we're bright enough to add this up, 2 times 136 is going to be 272, but then I got to add 2992 and 16 to it, so that's 3280. All right, so the moral of the story is sometimes you have to make changes to the original problem before you get started. So example 3 here, we had nothing. We had no formula that matched that. So that's the reason that we did all the foiling before we started. Then we split everything up and gave it its own summation. Okay, so I think you guys should be good. I'm going to zoom it out here in case you want to take a picture of the whole thing at once together. I will not be talking to you tomorrow. I'm just going to post that celebration. So have a good weekend. Hope you're staying inside. I have been inside and I am tired of being inside, but that's okay. So hopefully I get to see you guys soon. If not, you'll hear from me on Monday. So good luck with the celebration. Make sure you get that stuff turned in before 8 o'clock Monday morning, and then we'll go from there.